Lesson 3.4, we're looking at percent change and percent error. Lesson starts here on 157. We're going to go ahead over to 158. So on 158, we look at example 1. Percent change describes how much a quantity has changed relative to its original amount. Okay, so it's kind of like how much did it change compared to what it was. So on this example, we can see on the picture here, 32 inches last year, 38 inches this year. Crocodile, is that right? It's hard to tell. I think it's a crocodile. Anyway, it was 32 inches, now it's 38 inches. So what we're looking at, visually we could make a bar diagram to kind of see what's happening. So it was 32, now it's 38. So basically the change, we're looking at, we had 32, now 38. So 38 would be like 32 plus 6. Okay, so it changed by 6 inches. And the book's showing a little bit different. They're showing about using a percent equation to find that. I think there's probably a way we could do this that would be maybe easier for you guys. So when we do a percent change, one way that we can do that is we can look at what is the change, find the change, and then divide by the original amount. Okay, so kind of if we look at our definition, that kind of makes sense. It's how much it changed relative to its original amount. Okay, when you divide that out, if you do the change divided by the original amount, if you do it this way, you're going to get a decimal, and then you'll just need to move your decimal 2 spots to the right to get your percent. So on this problem, what we could do is look at, it went from 32 to 38 inches, so the change was 6. Okay, and again, since there wasn't a 6 there, we could show how we got that by taking 38 minus 32. And then the original amount was what it started at, so that would be the 32 inches. Okay, so if you do 6 over 32, means 6 divided by 32, and that will be 0.1875. And then move your decimal 2 spots to the right would be 18.75%. And again, the book got the same answer. It's just a different way of doing it. So however you want to work that out is fine. So if we look at the try it, what will be the length of the alligator next year if its length changes by the same percent as it changed this year? Well, it changed by 18.75%. So if we figure out what 18.75% of this length is, the current length, which now is the 38 inches, that's going to tell you how much it's going to change by this year. And since it's a bigger length, you take the same percent of a bigger number, you're going to get a bigger number. So it's going to grow by more than 6 inches this year. So that would be 7.125 inches that it's growing by this year. And then we can look at what its new length is going to be. So if we take 38 plus 7.125, that will give us the new length that we're expecting. Should be 45.125 inches. So example 2, last year a website had 40,000 visitors. This year it had 37,000 visitors. What is the percent change in the number of visitors to the website from last year to this year? So this time, this is what's called a percent decrease because the number of visitors actually went down, versus the last problem was a percent increase because the length of the crocodile went up. So in this case, we're looking at what that deficit is. You know, we went from 40,000 to 37,000. So again, you can follow what the book did if you want, or we can think of, you know, how much did it change compared to what it was originally. So if we think about it, was 40,000, now it's 37,000. When I find the change, I usually just take the bigger number minus the smaller number, because then we can think about, you know, was it an increase or decrease? Okay, I'm not going to worry about putting it in a certain order. So that's a difference of 3,000 compared to the 40,000 it was originally. So that's what the book has here now. And then if you divide that out, you get 75 thousandths. Move the decimal over 2 spots, and you can see that would be a 7.5% decrease. The next thing we're looking at on example 3 is what's called percent error. So percent error is just basically looking at how far off we are, maybe from what we predicted. So positive or percent error, it's the estimated value compared to the actual value, and it's always considered a positive percent. Okay, we don't say we were off by negative 7.5%. We'll just say we're off by 7.5%, for example. Okay, now percent error, estimated value compared to the actual value, basically is we're doing the same thing. So if you look at this, Sean estimated the attendance was 3,000. And then the actual attendance was 3,296. So the question is, what was the percent error? And round to the nearest whole percent. Okay, so it's really the same idea as what we did on percent change. Percent error, we're just looking at the change divided by the original amount. So the change is like how far off they were compared to the original. Now the original is, in this case, is the actual. Okay, so it's the change divided by the actual, you could say. And again, they did ask us to round this to the nearest whole percent. So if you divide that out like the book has, it's 0.0898 something. So if we round that, move your decimal 2 spots to the right and round that, would be about 9%. 9% error. So they were off by about 9%. And again, the book talks about, you know, let's subtract these and do the absolute value. Don't worry about it. It's always going to be a positive number. Just take the bigger number minus the smaller number when you're finding that percent error. So if we look at the try it, specification for the length of a bolt is 4.75 inches. Okay, so in other words, that's how long it's supposed to be. A machinist makes a bolt that is 4.769 inches long. What is the percent error of the bolt's length? So we're going to look at what the change was divided by the original, or change divided by the actual, if you want to look at it that way. Okay, and do make sure you're comparing to what actually was. Okay, so the actual bolt was 4.769 inches. So if we subtract in the numerator, the change is 19 thousandths, and then we're going to divide that by the 4 and 769 thousandths. So when you divide that out, this doesn't come out real great. It's 0.00398 something. Probably sufficient. They should really tell us what to do here, but probably sufficient if we go to the nearest tenth of a percent. So if you move it over 2 spots, that would be 0.4%. Okay, so that's less than 0.5% error, so that's pretty good. And usually there's a thing called like error tolerance, and so, you know, even though it's off a little bit, if it's, you know, within a certain percent of the actual of what it was supposed to be, then it's considered acceptable. If it gets too far off from that, then, you know, we'll have to either cut it shorter, or if it's already too short, then we'd have to just probably scrap it or adjust it down to the next lowest length. So if we look at do you know how, number 4, Lita's softball team won 8 games last month and 10 this month. What was the percent change in the games the team won? And was it an increase or decrease? Well, without even working anything, I can tell that part of it. We went from 8 to 10. Going from 8 to 10, is that going up or down? Up, and so that's going to be an increase for sure. Okay, and then the question is just what is that increase? So we'll do the change divided by the original, change divided by the original amount. And when you do these, we're talking about the change divided by the original. Original is what happened first. So what happened first in this case was what happened last month, which is the 8 games. So to find the change, we'll do 10 minus 8. The original, what they did originally last month, actually in this case would be the 8. So 10 minus 8 is 2. 2 over 8. You might observe that that would reduce to 1/4, which you might know as 25%. Or you can just divide it out. You get 0.25 and then move your decimal 2 spots. And one way of showing that as an increase, we can just put an up arrow next to that. This is something you might notice if you ever watch stock reports. They might have the up arrows and down arrows showing that. Only theirs are going to be by you know, how many dollars and cents a stock went up or down versus what percent it went up or down usually. So on this problem, number 5, we're trying to find the percent change in the price of the gallon of gas to the nearest whole percent, and is it an increase or decrease. So we want the change divided by the original. How much did it change compared to what it was, in other words. And we're just going to keep these numbers the same. They always have that tenth of a penny for whatever reason on these gas prices. So the $3.49.9 is our original price of the gas. So if you subtract that, would be 42 cents difference. We're going to compare that to what it was originally. So when you divide that out, you get like 0.12003 something. And again, they should tell us, oh, they do tell us this time, nearest whole percent. So move your decimal 2 spots, it'd be like 12.00 something. So that's going to be, nearest whole percent would be 12%. The gas went from 349.9 to 307.9. So price went down, so that would be a 12% decrease roughly. Number 6, several students measured a 25 millimeter long nail and wrote the measurements shown in the table below. Whose measurements had the greatest percent error, and round to the nearest percent. First thing we got to think about on this problem is that this time the actual length of the nail is 25 millimeters. Just people didn't necessarily measure it quite right. Does that make sense? Okay, so the actual length of the nail is the 25 millimeters, and then we're seeing how far off their measurements were from that actual length. So for Lane, we could figure 26 minus 25, that's the change, divided by the actual. So that's 1 over 25. If we multiply both these by 4, that'd be 4 over 100, which would be 4%. Or you could divide it out. It would be 0.04, which is 4%. Tanisha is a little further off on the low end, actually. So that is off by 2 over 25. That's twice as much, so that's going to be 8%. And 1 measured at 25 millimeters. Well, he measured it at 25 and it's actually 25. So that would be 0% error. So the question here also asks whose measurement had the greatest percent error, which you probably, if you think about it, just think about who's furthest off from the actual length. So that's going to be Tanisha. And, you know, if they want specifically what the percents are also, though, definitely we've got to do that. But if they don't ask for the percents, they just say who has the greatest percent error. It's who's furthest away from the actual. Okay, so this gives you an idea of how to work with percent change and percent error.